This is note 7.2 part 2, molecule polarity and shape. So before, when we discussed polarity, polar covalent bonds, we said, hey, is there a polar bond between the two nonmetals? And in other words, do they have strong, weak bonds between, here, let's just say, strong was nitrogen, oxygen, fluorine, chlorine. Did any of those exist paired with a weaker nonmetal? If the answer was yes, then it was polar. Okay? If the answer was yes, then it's polar. Again, if you don't recall this, you may want to make a note of it. Strong, weak. The four strong nonmetals: nitrogen, oxygen, fluorine, chlorine. That's the four strong nonmetals. Okay? Were they paired up with any of the other nonmetals? If the answer is yes, then it was polar. Now, after having learned about the elephant and human interactions in the context of tug of war, now let's go ahead and transfer that idea to the strong, weak covalent bonds again. So now we have to ask, does it have polar bonds? If the answer is yes, then you have to say, okay, do those bonds cancel? And how do I know if the bonds cancel? Well, you have to look at the shape of the molecule. That's how. Okay, so that's how this all plays into one another. There can be polar bonds, and the molecule can still be nonpolar overall because those bonds cancel. So now we ask, does it have a polar bond? If the answer is yes, do those bonds cancel? If no, they don't cancel, then it's polar. Okay, what's an example of that? Look. Polar, right? Strong, weak. Strong, weak. Those bonds do not cancel. They are polar. Let's look at one where we've got strong, weak, but there's a strong there, right? Both of these are strong. There's a weak in the middle, but check it out. That strong, weak is going this way and another strong, weak going that way. Okay, so they cancel. So is this molecule polar? No, it is not. No, it's not, because these two forces are canceling each other out. Okay, so again, does it have polar bonds? If yes, do those bonds cancel? No, then it's polar. Yes, it's nonpolar. Okay, it's nonpolar. Again, these two cancel each other out. Therefore, this molecule overall is nonpolar. There is no winner. Let's look at some other examples here. Check this one out. Let's look at this one. More human elephant tug of war examples. Human in the middle and four elephants all around. Well, look what's going on here. Look what's going on here. You've got that happening, right? And now these guys, this one cancels that out, and this one cancels that out. So even though you've got strong, weak interaction going on here, this overall molecule is nonpolar. Nonpolar, you guys. Okay, let's do one more example using the same idea. Let's go like this. We'll go like this one more time. And I think you probably know where I'm going with this. We'll do this. Here we go. Aha. How does that change the dynamic? Well, now everything's going towards this elephant. Right? The elephant's just going to pull these guys like they're not even there. So this is polar. That's a strong, weak interaction, right? Strong, weak interaction, but there's no other strong, weak down here to cancel it out. Okay, there's no other strong, weak down here to cancel it out. So what if there was an elephant here? Would that cancel it out? Yeah, it would, and then it would be nonpolar. And that's, you could make the argument, let me say, you could make the argument that it would be nonpolar. Whether it actually is or not, you'd have, well, it would be. Anyway, you won't get one that's that ambiguous on the test. You'll get something that's very clear like this. Okay, these are all very clear. You can clearly look at them and see they're lopsided in terms of the strength of the elephant versus the humans. Okay, as is this one here, as is that one there. Okay, I'm going to make sure that it's very clear that you don't have to sit there and try to imagine, okay, if there's another elephant there, would it cancel? It's not going to be that complicated. Okay, so let's go to our notes then. Our note 7.2 says the following. A lot of this is filled out for you. For each of the following, draw their Lewis structures and determine whether each is polar. Then shade in the distribution of electrons in the picture. You don't have. Let's not do that. Let's not do that. I don't want to deal with that right now. Indicate the relative charge of the molecule. Maybe we'll answer that in a second. Okay. So O2, our Lewis structure for O2 looks like this, if you recall. Let me zoom in a little bit. By the way, O2, I don't know, maybe it's just me, but it seems that O2 keeps coming up over and over again. So maybe you ought to consider that. O2 looks like this. You've got a strong interaction with a strong. Is that polar? No, it is not. It's nonpolar. Okay? Strong and strong. Carbon and oxygen. Carbon is weak, oxygen is strong. So carbon monoxide. Now let's see, we've got 1, 2, 3, 4, and this. I'll draw it out. I'll do the whole thing for you guys so you can see what I'm doing. Okay, we got that right there, can interact with that. And then you got a lone pair over here. So how's it going to look? It's going to look like this. C with a double bond to O, lone pair on this side, and then you got 2 lone pairs over there. Okay, is it polar? Yes, it is polar. That's a strong with a weak, right? Strong and weak, so that is polar. Okay, again, if you can't, maybe should I draw it? No, it looks like you guys can see it. Okay, now I purposely did supplemental notes using these examples in order so that you could go back through and sketch those shapes in order. I did that on purpose so that I don't have to explain it as I go. Okay, so let's go ahead and just draw the Lewis structures for the supplementals here. CH4 is going to look like this. You've got a C, H4. That's the Lewis structure for CH4. NH3 we know looks like this. NH3. And don't forget that lone pair up top. H2O, we all know what that looks like at this point, I hope. H2O. And you can draw your lone pairs in like so. CH2O. Alright, this one's a little trickier. That's why I drew it this way for a reason. Even though it's not really, even though it should be that other way that I showed you. But let's go ahead and do it. We'll do carbon. We've got 1. I'm going to do this. I'll draw 2, 3, 4 like this. And the reason why is because that double bonds very nicely to oxygen up here. Okay. And then if you were doing this here, put hydrogen right there and a hydrogen right there. Okay, there's a reason why I did it like that. In reality, it would be more of a triangle shaped. Okay, but I knew that some people were going to be working out the Lewis structure. They were going to do the dots, so I drew it that way. Okay, but that's what that one looks like. NOBR. NOBR looks like this. Oh, you know what? I'm going to pause it for a second. I'll do NOBR. I'll work the whole thing out for you. You don't have to copy this. You can just watch me do this, or you're welcome to copy this in your notebook if you want to, but you don't have to. There's N, here's O, and here's BR. BR, we know bromine just has. I'll do the whole thing. Bromine's a halogen. All the halogens have this configuration. Okay, so let's draw our lines. Yeah, 1, and then check this out. We got 1 there. So NOBR is going to look like this. Once we clean it up, it'll look like such. And then it's a halogen. You don't have to draw in all the dots. You can if you want to. It's not wrong, but you don't have to. Anyway, there's NOBr. It looks like that. Okay? And it's actually got a little bit of a slant to it because this side, or because the bonding sites for the nitrogen go down. It goes down at a little bit of an angle. So if I wanted to be really, really proper, I would do it like this. I would accept this on a test. Let me just be clear. Okay? It actually looks a little bit more like this. And again, you can get out the model for nitrogen and figure out why that is. But that's NOBr. Okay, it's going to look more like that. All right, let's move on to the next one then. The next one's CO2. Well, CO2 is, I had you guys make that with the model, using the models. You remember that? That's CO2 right there. Okay. And then last but not least is HCl. Hopefully you guys remember. This is an easy one. HCl. That's just a halogen with a hydrogen attached to it. Okay, HCl. So there you have that. I'm going to stop this one and then we'll finish it in the third video.